So first topics about network design. In Cisco network design, we are using this design called campus design. In campus design, we have this kind of pictures. We have some access layer switch. We have some PCs. All the PCs, they are connected with access layer switch. And then access layer switch is connected with distribution layer switch. And distribution layer switch, they are connected with routers. So enterprise network environment, we have this kind of design. And access layer switch, mostly they are layer 2 switch. In layer 2 switch, all the end user device, let's say IP phones, wireless access point, those kind of device, they are connected in access layer switch. After that, you can see we have multiple links from each of the switch, and especially these two switch, they have also redundancy as well. So this switch can go via both of the distribution layer switch. And this switch, they have multiple links to this distribution layer switch. And from distribution layer switch, we have the routers. And router may be connected with some other areas. So that's how campus design topology built. And need to remember that access layer switch, distribution layer switch, and we have core layer switch. Now there are some other design part. Some of the topology we built, like this is called star topology. In star topology, we have switch in the middle, and some of the PC, they are around the switch. And this is kind of like full mesh design. In full mesh design, we have all the switch, they connect with each other, they are full mesh design. So you have star topology, we have full mesh, sometimes we have partial mesh, where all the switch, they are not connected with each other. And sometimes you have full mesh and partial mesh together, we call them hybrid. So based on the scenarios, we may have star, full mesh, partial mesh, and hybrid, different kind of design in our network. Another kind of design we have called two-tier design, where there's no core switch in here. You can see we have building one. Building one, we have all access layer switch. Then you have distribution layer switch. Building 2, we have access layer switch, distribution layer switch. Building 3, we have access layer switch, we have distribution layer switch. This is mostly large office or hospital or school or university campus. They may have multiple buildings like that. And all the buildings, they connect with each other in this way with the network part. Let's say all the distribution layer switch, they have connectivity with each other. This is one kind of design where we don't have any core layer switch. We have access layer switch and distribution layer switch. But in another scenario, we can have, access layer switch, then we have distribution layer switch, and you can have core layer switch as well. If we have core layer switch, you can see then we can reduce a lot of connectivity. And all the distribution layer switch, they connect with multiple core layer switch. In this way, we can reduce the connectivity. So access layer, distribution layer, and core layer switch. So that's how we can have three-tier campus design. So based on the circumstances, again, we can have three-tier campus design. Now, another scenarios we have, this is called SOHO. SOHO stands for small office, home office, where we have the ISP who provide the internet connections, and ISP connect with our cable modem, It could be cable modem, DSL modem, or any other medium where ISP terminate their connectivity. After that, from that device, we can get the connectivity in our router. And from the router, we have switch. Switch has many different ports. Switch has many different ports, and all the PC they connected with those ports. And switch and router, we have this kind of connectivity, and router and that device, this kind of connectivities we have. And then switch connected with another access point. So this access point main job is to provide wireless network connectivity. So if you looked at your home network, you may have, small routers that provide routing functions, a bit of switching functions that may have 4 ports, and that may provide also wireless connectivity. So it's kind of like an all-in-one, but many businesses or many, home network, they have those kind of small router, but in the businesses, we have routers, separate router, separate switch, and separate access point. If you have a bit large office, you may need multiple access point in order to provide the coverage, wireless coverage. So if we want to troubleshoot any network, this kind of scenario we need to have in our mind. Let's say you're troubleshooting someone having some problem. They may have problems around internet. They may have problems around connectivity. So there's a routers, there's a switch, there's access point. So issues can be anywhere in around these areas. This is a firewall. This is a kind of like a software firewall, or some context it could be the hardware firewall. So this kind of setup we need to keep in mind. If you go to troubleshoot any network, then you may look for where is the modem or a internet connectivity, which way it came, and after that, where is the router, switch, access point, where is all the device, we need to find out. And based on that, we can do some other troubleshooting. Now, another types of switch we have available in the market, that is power over Ethernet, PoE. So PoE switch can provide the power to these IP phones or maybe wireless access point. So this device, they need the connectivity. They need this kind of device, they need like connectivity from the wall socket. So basically, instead of getting power from the electrical outlet, this device can get the power from the switch with the Ethernet cables. So that's a very good options, and this is very popular in many businesses. They're using this PoE switch these days. In PoE switch, we have many different options, depends on the switch. Let's say some switch provide 7 watts. Some PoE switch, they may provide 15 watts. PoE plus provide 30 watts. Ultra PoE provide 60 watts. Ultra PoE plus provide 100 watts. So based on your requirements, you can choose these power options. And Ethernet cable, we know that Ethernet cable, we have 8 different pins, 8 different pairs, or 4 pairs, but 8 different individual cable we have inside the Ethernet standard. So out of those 8 pins, 2 pins, or this is called like 2 pairs. So they're going to provide the power. And this one for the more watt requirements, we need 4 pairs and 4 pairs like that. So that means Ethernet cable, some of the inside one of the Ethernet cable, we have 8 different pairs, but some pairs will be used for communication purposes, data communication purposes, some pairs can be used for this power as well. So this is important when you purchase any device, when you select any switch during the time, you need to think about these power consumptions, and based on that, you can purchase that particular device. Now switch, some of the stuff we know already about switch. Switch is a layer 2 device. Switch has separate collection domains. So collection domain means is each of the switch individual links considered to be individual collection domain. That means this individual link bandwidth will not be shared by other link, or it will be full duplex mode. Any communications you do in here, those communications will not be shared by other link. So that's called collection domain. So each of the switch, each of the individual link considered to be individual collection domain. So if this switch has 4 ports, it has 4 collection domain. Switches are faster than the hubs. Hubs is like a layer 1 device. Hubs looks like a switch, but it supports only 10 Mbps speed, and it's also hub duplex. That's why hub is not popular these days. So switch, they are faster, and switch individual link is not shared by any other link. So all the communications happen in a faster way. Now, some of the informations we need to know about switch. Usually switch is layer 2 device, and switch main job is to forward the frames and broadcast the frames. Has the destinations MAC address of FFFF, FFFF, FFFF. So let's say switch broadcast to all other devices with this MAC address. And switch actions. Switch has some capabilities. Part of that capabilities, it knows when to forward or filter a frame based on the destination's MAC address. Learning MAC address from the source MAC address of the frame. So switch work with MAC address, switch learn the MAC address, switch knows about the destination, source and destinations, both MAC address. But let's say if switch doesn't know the MAC address, then it will broadcast to everyone. Switch will broadcast to all the devices connected with the switch, and all the devices, they will reply with their MAC address to this switch. So this is the switch characteristics. And switch also have another capabilities. This is called spanning tree protocol. And with these features, it can prevent the loop. It can prevent the loop. So layer 2 loop-free environment with other switches using spanning tree protocol. So if there's a chance to have a loop in our network, switch has this spanning tree protocol features. With that, it can prevent the loops. Now forward and filter decisions. So switch can forward and filter a frame. Let's say a frame came into F0/1 in here, and then switch knows where to forward a frame and where not to forward a frame. And you can see the switch MAC address table. It knows all the MAC address and their interface or port. So switch learn all the device MAC address from this each of the interface. You can see this is the MAC address FA01, MAC address FA02, MAC address, and MAC address. You got all these MAC addresses. So this is the forward and filter decisions can be taken by this switch. In case if we have two switch, let's say we have switch 1 and we have switch 2. In case we have two switch, Then you can see the switch 1, it knows this MAC address, and also with this gig01, it knows the other two device MAC address as well. So that means switch can learn the MAC address from the another switch as well. So that's the one of the characteristics we have in the switch. Switch can learn the MAC address of the remote device as well. See, with gig02, it knows about these two MAC address. So some device connected, it knows that. Also, some device may be connected with another switch, it knows that as well. Now build the MAC address table. Initially, see the MAC address table is empty. And when first MAC address came into the switch, then it will keep that one. So initially MAC address table will be empty, but slowly switch will learn all the MAC address and it will start to build the MAC address table. Maybe 1 MAC, 2 MAC, 3 MAC, 4 MAC. In this way, it will store all the MAC address informations from each of the switch. Now flooding frames. If destination's MAC address is not yet in the MAC address table, the frame is forwarded out to all interfaces using the process called flooding. So that means if switch doesn't know the MAC address of a device, so switch will broadcast to everyone, and then everyone will reply with their MAC address, and this process is called flooding. And switch never forwards a frame out the same interface on which it arrived. So that means switch will never forward a frame, like switch receives one of the frame, so same frame it will never return from the interface, because if it does that, then it will create a loop. So that's why switch will never forward a frame out the same interface on which it arrived or received. Now some of the informations, like how to check the switch MAC address table, we can say show MAC address table, and how to check the PC MAC address, say ipconfig/all. So these two command we need to remember, right? If it is a switch, we can apply this show command. If it is PC, we can say ipconfig/all. In this way, we can learn the switch MAC address table informations. Now, spanning tree protocol. STP protocol used to avoid loops in the LAN network. Flooded frames cause broadcast storms. So let's say we have 3 different switch connected, and this is Larry connected with this switch, Bob connected with this switch, Archie connected with this switch. Now, if Larry sends some informations to Bob, and if Bob computer is turned off, then what will happen with the frame? So switch always forward the frame. Switch never backward the frame or return the frame. So that means switch will forward the frame. If switch forward the frame, it will go to next switch. And then this switch will also forward the frame to this switch, Larry switch. So in this way, they will always forward the frame, and frame will actually keep going around these switches. So Larry will go to Bob, Bob will go to Archie, Archie. So that's how frame will travel in this link. But this is kind of like create a loop, and that's why we have spanning tree protocol. Spanning tree protocol, it use some methods, and with that method, it's actually block the redundant link. That means, let's say this switch has one link and another link. So spanning tree protocol will block one of the redundant link based on some factors. But once one link is blocked, then what will happen? The frame will go to this Bob switch, and from Bob switch, you'll forward that one to Archie switch, After that, frame will drop in here. Frame will never return. So in this way, spanning tree protocol can avoid the loops in our network. And this is only happen when you have multiple link or redundant link. During that time, spanning tree protocol will stop the loop. Now, based on these discussions, we have some scenarios in here. We have some collation domain. And in this scenario, we can see we have one hub. This is the hub. So hub has actually single collation domain. That means if we put 2 PC or 4 PC, it does not matter. Still, it will have same collation domain. And you can see that we have another hub in here. And in order to stop the collation domain, we have a bridge in here. Bridge can separate the collation domain. So collation domain means, let's say, if PC2 sends some informations to PC3, so PC1 will get that frame as well. So that means if you do something, all other devices in the hub, they knows about that as well. So if PC3 sends something to PC2, PC1 will get that frame as well, which is unnecessary because PC1 don't need that frame. So if you have a hub, it does not matter how many PC you connect, still considered to be only one collation domain. But when you go to switch individual link considered to be individual collation domain. That means if PC3 sends something to PC2, those informations will not go to PC4. So that's why switch is faster and switch is better. And switch individual link considered to be individual collation domain. So that's how in these pictures we can see switch has this hub has one collation domain, then this hub has another collation domain, then this switch has 1, 2, and 3 link. So 3 collation domain. Altogether, we have 5 collation domains. Now, if we put 2 more PC in this hub, still we'll have 5 collection domain. But instead of this hub, if we connect 2 more PC in this switch, then we'll have 7 collection domains. So that's how the collection domain functions. Now we have broadcast domain. So what is a broadcast domain? Broadcast domains, they are related with our IP networks or subnet. You can see the router only can separate our network in multiple broadcast domain. Let's say router has this one interface, so entire interface, this sections is more on one one broadcast domain, and this side we have another broadcast domain. That means broadcast domain is mostly related with IP. That means router this side we need to have one subnet, and router this side we need to have another subnet. So router will have 2 different subnet. So router has 2 different link and 2 different subnet. They are connected with 2 different link. So if router has three interface or 3 links, so that means we need 3 different subnet. So router individual link considered to be individual subnet, or individual broadcast domain will have if we have router. That's why router is very important, because router can separate the broadcast domain. Broadcast domain means if any broadcast happen in this area, this broadcast will not go to other side of the router. So that's how router can separate the broadcast domain. Now in our switch, we have some other mechanism. This is called auto negotiations. This is related with speed. Let's say some device they may communicate with 10 Mbps speed. Some device they may support 10 or 100 Mbps speed, and this device may support 10, 100, 1000 speed. So different device support different speed, but our switch support all kind of speeds. 10, 100, 1000, 10, 100, 1000, like that. So this switch supports all kind of speed. But when they communicate, let's say this PC want to communicate with this switch, maybe they communicate with 10 Mbps, this one maybe 100 Mbps, this one maybe 1000 Mbps. It's a full duplex. So in this way, this device they can communicate. And by default, these auto negotiation capabilities enable in Cisco switch. So any kind of like speed they want to communicate with switch will auto negotiate the common speed, and then they communicate with that particular device. But if you have a hub, let's say hub only support 10 Mbps speed, but switch support all kind of 1 GB or 1000 Mbps full speed. So if you connect a hub only support hub duplex. So even if your switch supports 1 GB speed, but hub, because of the hub, it supports only 10 Mbps and hub duplex. So usually we don't use hub these days, but maybe some legacy system still they may have some hubs connected, and they are working fine. So pretty much some network maybe is not making a lot of issues. So you can still find some hubs in the some old network.